In this lecture, we're going to be taking a look at the last portion of chapter 5, which is on integers, and we're going to look at tackling multiplication and division with integers, as well as the order of operations and inequalities. So the first integer multiplication method is what we call the pattern model. So we would basically seek to figure out what is 3 times -2 by using the repeated addition of -2 plus -2 plus -2. The nice thing about that is they already have a foundation in the arithmetic for addition, so they know that the sign is going to be negative, and it's clear why the sign is negative. A lot of times when we just jump to the rule of if one value is negative, the answer is negative, students don't know the why. So the pattern model is an excellent introductory way to work your way into integer multiplication models. We can also use the commutative property to then show, hey, -2 times 3 is also going to be -6. So again, we're just really building that understanding of what's happening. So this is an excellent investigation to do with your classes. Now, the chip model we saw in addition and subtraction, it can still be used within integer multiplication. We will use red dots for negatives, black dots for positives, or we can actually use the symbols. So if I have 3 times -2, I have 3 groups of -2. So I would put 2 red dots, I would circle those groups, count up what I have, it's 6. There are 6 red dots, so the answer is -6. This is a really good visual exploration for when you have a student that really needs to see it happen. Now the chip model can continue on and start with a value of 0, and we can start removing groups of chips. So I can start saying, well, I'm going to take 6 chips over here and move them over, and so that I have the 6 red chips remaining. In a charged field model, I can remove the 3 groups of 2 negative charges, and I can be able to start showing I have 6 positive charges. So this is kind of what you're looking at when we have a negative times a negative. In a number line model, this isn't the greatest model for multiplication. A lot of students aren't going to get this model, but it is useful because when we start talking directions like north, south, east, west, and word problems, it does help them utilize that. So I can teach them in a word problem, if I'm going east at 3 miles per hour, I'm going to the right. If I'm going west, I would be going to the left. So that I can then build upon their understanding of integers in the word problems. I don't really think the number line is really good of a model. Maybe you think differently, and that's okay. But it's good for showing movement in a word problem, but not as good for just showing static multiplication of -3 times 2. They're going to have more questions about why are things positive and negative there. That's going to be a kind of complicated. So we have a couple of theorems here. If A is greater than or equal to 0 and B is greater than or equal to 0, then the product is going to be positive. So basically, if A is positive and B is positive, then their product is positive. If A or B is less than 0, which means it's negative, and you multiply them together, then the answer will be negative. So if you have a negative times a positive, the answer is negative. So for all integers, we have what we call this closure property we've talked about a couple of times, that when we multiply, we're going to get an integer. We're not going to get a fraction if I multiply 2 integers. I'm not going to get a decimal if I multiply 2 integers. I'm going to get an integer. And multiplication is commutative, just like we saw. It's also associative. So make sure you're keeping those straight. The identity property in multiplication means I can multiply any value by 1, and I get that resulting value back out. The distributive property applies to integers, just like it did in our previous section, and the zero multiplication property also applies, just like it did to regular multiplication of whole numbers. So here's a few examples. If I'm looking at these, I have -1 times A, which is going to be negative A. If I have a negative A times a positive B, the answer will be negative. If both of my values are negative, the answer will be positive. And that's, again, where that repeated multiplication is very helpful. Repeated addition. If I have a distributive property, you're going to distribute the signs with it. So if A is positive times B is positive, that's going to be positive. If A is positive and C is negative, it's going to remain the subtraction of A times C. Here are some examples where we're going to be doing this. So we're going to distribute -3 into the parentheses by multiplying every term by -3. And I'm going to get -3x plus 6. Here, I'm still distributing. I really dislike the idea of FOIL. You're going to hear me say that a lot in this class. So I'm distributing. I'm distributing an A to the first parentheses, and I'm distributing a B to the first parentheses. That's what I'm doing, is just distributing. Once I distribute, I combine my like terms, and I wind up with A squared minus B squared. So if you see it as a distribution and not as a FOIL, that's going to be beneficial. So the result here is something special that we're going to see a little bit more as we get into quadratics, and that's going to be that it's the difference of squares formula. Now, using that difference of squares formula, we can simplify the following expressions. I know if I have the negative times the positive, I'm going to get a negative answer. So that's where when I distribute that B to the second set of parentheses, this negative B, it's creating a negative there. The difference of squares is also going to be the first term squared minus the second term squared. So you don't have to do the full distribution there. You can just square the first term and square the last term. The same thing applies in part B. It's the difference of squares formula because I have the exact same thing in parentheses and only the sign between them is different. So I square the first and I square the last. In this one, I can take this out. Let's see, I can simplify this into this statement. I would probably not use the difference of squares here, guys, and especially in the lab, it doesn't force you to use it. I would just do x plus 3 times x plus 3, and then x minus 3 times x minus 3, because what they're doing here is some regrouping, and you will still get the same answer of 12x. Now, when a distributive property over subtraction is written in reverse, that is called factoring. I'm dividing by some value and I'm factoring it out. So that's a factor situation. When the term has been factored, I say it's factored out. So in AB minus AC, they had a common factor of A. I factored it out, and in a way, you're dividing AB by A and AC by A. Now, both the difference of squares formula and the distributive properties of multiplication can be used for factoring. I can apply both of those to a factoring situation. If I look at A, I have something squared minus something squared. That's the difference of squares. So I'm going to apply the square root of x squared is x, the square root of 9 is 3, and the only thing that's different is the sign in the parentheses. In part B, I can apply the difference of squares, so I have to actually figure out what is x plus y squared, and then I'm going to have to fully simplify that out. Here in C, I can take an x out of each term because they have a common factor of x, and then I'm going to factor it out in that reverse distributive property. In 3x minus 6, each of those terms has a 3 in common, so I can factor that 3 out. So I would do 3x divided by 3, 6 divided by 3. That's how you get what's in the parentheses. And in the last one, we can factor out an x squared, and when we do that, we can simplify 5 minus 2. Now, if I want to look at integer division, we're going to have some of those same rules with the sign. So if A and B are any integers, then A divided by B would also be able to be described as A equals B times some value C. So it's kind of like when we relate addition to subtraction. The quotient of two negative numbers, the division, if I divide two negative numbers, it's positive. If I have one negative and one positive, the answer is negative. So when you're completing the division, you're going to do 12 divided by 4 like normal, but my answer is going to be negative because I have one negative in the problem. And you should see I get the same answer from A and the same answer from B. Now here I have both of my numbers are negative, so I'm going to get a positive. In D, one of my values is negative, but 12 does not divide evenly when I divide it by 5. So it is not going to be an integer. If I have AB divided by B, that's just going to leave me with A because the B's are going to cancel. If I have AB divided by A, that's going to just be B because the A's are going to cancel. Now, the order of operations comes up a lot on social media memes when we're working with these, so I want to take a few minutes. When we do that, exponents come first. Then comes multiplication and division from the left to the right, and that's where the most common mistakes are made, is that you have to do things in order from the left to the right. Then addition or subtractions is done from the left to the right. And then parentheses must be done first according to these rules. So we'd have parentheses, then exponents, then multiplication and division, then addition and subtraction. So if we look at this, the first thing I have to do is complete the multiplication of 5 times 4. So 5 times 4 is 20. So I have 2 minus 20 plus 1. I have to go left to right. 2 minus 20 is negative 18. Negative 18 plus 1 is negative 17. Then in B, I have to do the parentheses first. 2 minus 5 is negative 3. Then I have to do the multiplication first. Then I have to add 1. In part C, multiplication comes first. So 3 times 4 is 12. 5 times 2 is 10. And then I'm going to do the addition and subtraction from left to right. These are some additional examples. I want to talk about part E for just a moment. When I have part E, negative 3 to the 4th power is repeated multiplication. Now, remember, 2 negatives multiplies to give you a positive. So if I have 4 negatives, it's going to follow that same rule since 4 is a multiple of 2. Now, what's different in part F is that I have the negative in front of the 3 to the 4th power. That means the negative stays hanging out front the entire time, and the answer is actually going to be negative. That is probably one of the most missed problems that I see, especially in younger students, is that they forget that the negative in front of a number means the answer is also going to be negative. Now, if I start ordering integers, I'm going to look at the number line, and I'm going to order them according to where they appear for 0. So I've got some fancy inequalities here, but I'm not really worried about them. Let's just look at what it actually means. If I have x plus 3 as less than negative 2, and I want to solve this for x, I'm going to have to add the opposite to both sides. So I would add a negative 3 to both sides to get x is less than negative 5. In part B, I'm going to have to add the opposite of 3 to both sides, or negative 3. So I'm going to add 3, and then I get negative x is less than 8. Now, to get the negative to the other side, you're going to multiply x and 8 by negative 1. When you multiply by a negative number, it's going to flip the inequality sign. And I'm going to post another video that goes a little bit more in depth on this because I think this glosses over some things by just a little bit. If x is less than negative 2, then find the values of 5 minus 3x. Well, let's start looking at this. If it's less than or equal to negative 2, I could just plug in negative 2 to get a feel for where it is. When I do that, I can see that I'm going to get something in the form of negative 3x is greater than or equal to 11. Well, the set of integers that are greater than 11 would be 11, 12, 13, 14, and so on. And that's the culmination of this lesson. I will post a little bit more in depth about inequalities, so you have the option of watching that.